Hello, let's continue doing cyclohexanes. Remember that when we have a mono-substituted cyclohexane, the substituent will prefer to be in equatorial due to 1,3 diaxial interactions when it is in axial. And the larger the substituent, the more difference in energy will be between one conformation and the other. And for example, if you had isopropyl, then the chair that has the substituent equatorial will be even more populated than in the case that you have a metal group. And even more so if you have a tributyl group. This practically locks the chair in the conformation where the tributyl is equatorial, because being so large, 1,3 diaxial interactions are too big in the other chair. So having said that, now we're going to use that concept to analyze the conformations of this compound. This is a 1,3 disubstituted cycloalkane. And here we have an isopropyl group, so quite large, two metal groups. And here I have a metal. Also notice that what we said before, relationship in the space, a special relationship between the isopropyl and the metal is opposite side. This is up, this is down. So this is a trans, a stereoisomer. So this is trans. All right. Now let's look at the chairs to do our analysis. So first I'm going to draw, say, one chair, and here say up. So I'm going to do my isopropyl group here. So it has two metal groups. And so carbon 1, 2, 3, and I need to draw the metal down. So it will be here. So that's one chair. Now I'm going to do the flip chair, right? So now this corner that was down is going to go up. That's the central part. Right. So now in the flip, this that was axial, the isopropyl will go equatorial. And this is still 1, 2, 3. And the one that was equatorial will go axial. And so, yeah. So now what I want you to notice is that still the relationship in this space, right? Up, down. So this is trans. When you do the ring flip, this should happen the same. So this is up, down. So trans, that is, you need to double check always when you're drawing your chairs. If you didn't draw it accurately, then you may have the wrong isomer. All right, so here we have the two chairs. In the two chairs, we notice here that we have, yes, one substituent axial and the other in equatorial. And here I have this in equatorial axial. But actually, which one is the preferred conformation? And here we go by the size. Remember that we said the larger the substituent, then they rather be in equatorial. So even for isopropyl is also very big, so the conformation is preferred conformation, almost not as large as interbutyl, but really is large. So you will have most of the molecules will prefer to have that in equatorial. So what that means is between these two molecules being larger, the 1,3 diaxial interactions when isopropyl is in axial, then you will rather have the isopropyl equatorial. So this one is a preferred conformation. It is no longer, when the two substituents are the same, yes, it is 50-50. But here you need to consider the size of the substituent. So the larger substituent, you need to put an equatorial in that is the preferred conformation. So conclusion is the equilibrium is shifted to that side. So most molecules are going to have the isopropyl group in the equatorial position.